Very good evening to all. So welcome back to the class and to the bootcamp day 4. So today what we are going to discuss is on a plate load analysis, surface load analysis, area load analysis. So all these topics we are going to go ahead. So for day 4 today, what we are going to discuss is completely on the analysis part. So what is the need of analysis and what StatPro is doing all about? So what this StatPro is doing, how that analysis is working behind the screen, so that we are going to discuss in day 4 on bootcamp. So coming to that, so to the sections. So these are the sections which you are going to discuss today. So analysis using StatPro. So how you want to use StatPro for effective analysis, and how this StatPro is using the programming and how this work is going behind the screens, that we'll be discussing. And further that, we have manual versus software. So I have some data, some handwritten calculations. So I want to check with the software whether my software is giving the similar kind of answer or not. So that we are going to discuss today with manual versus software with basic beam. So let us take a small beam example. So here we are going to talk about a beam example today. So how this beam example, what you study in a theoretical classes, that is in the structural analysis, what you studied, how you draw shear force diagram, bending moment diagram, and then used various formulas. So that the manual versus software. So how the software is going to show your results. So that we are going to discuss. And then the most important part is your area load, floor load, plate load, and surface load. So you might be looking quite similar here. So the units for all this part is on either the kilonewton per meter square. So the unit is same. So for all this application, area load or floor load or plate load or surface load, the unit is going to be same, kilonewton per meter square. So there is no difference in that. So but what is the application? So that is the biggest question here. So for which purpose I need to apply this? So this is a application oriented. So for which and all elements, so which element I should apply a plate load, for which element I should apply a floor load or surface load, all these things. So basically to understand this 4 heading, so this 4 heading is basically covered with 2 basic principles. So I will come to that topic when I reach this topic. I'll explain you 2 main basic principles, what is going to be happen over here. And then finally we are going to see the structure wizard overview, how we are going to see the structure wizard overview applications, right? So with that, we are going to move further, how we want to do the analysis in StatPro. So to start with this analysis with StatPro, so how you want to do is, one is pre-analysis. One is called pre-analysis, and another one is called post-analysis. So what is pre and what is post? So this you should understand. So the pre-analysis means the input which is going to be taken by the software from the user. So from user, you are going to give certain inputs. So let it be a seismic weight, or let it be a wind load analysis, or simple static load analysis. So these are certain inputs. So what is my beam size? It should be, or what is the load I should apply on my beam. So that is a pre-analysis. So I'm going to give as an input. So that will take care of your static load check and your value for your mode shape. So mode shape, last class I showed you on earthquake engineering. So how the mode shape, the behavior of building. So how this behavior of building is happening with different time period, how this mode shapes are generated. So that is the main part over here. And then the load data only, I need only know about the load concepts only. So I can go for load or all. So by default, we go and stand over here. So by default, all whenever you do in the lab, we go and stand over here. So you think that if you give all, so everything is completed over that part. So but in the lab part, so whatever you've done by selecting all, it's okay. But in the industries, how you check only the load, static load conditions. So we prefer either static check or static load. So quite similar. So we'll be preferring this 2 part. So you want to only need the load part. So we don't waste our time in going to design or some unnecessary post analysis. So I need to only know what is the reaction, what is the load of the structure. So I go for only this two part, right? So now over here you can see number of tabs which is reflecting on the screen. So perform analysis, P delta analysis, or cable analysis, and non-linear and pushover, buckling, all buckling class analysis, all are there. So these are certain advantage level of analysis, how the software is going to do for a dynamic inputs also, right? So on the other side, we have a post analysis. So what is the meaning of post analysis? So I have done my analysis by using a pre-input. So what are the user inputs is given to the software? So the software is running the analysis, and I want to know with that result additional or extra. So post is called something called extra. So I want to know about some extra output for my system, or sorry, structure. So what I can show, so I can show some kind of drift analysis, how the building is going to drag, some kind of drift analysis. So this is a building. Then I have analyzed with the loads or some lateral forces. So what will be the drift? So if I have a number of floors, for each floor, what will be my drift value? Suppose I want to know that. So that will be done in post analysis. So what is the displacement at this particular point? So what is the displacement at this point? Or what is the displacement at this point? So I can get from story drift. So here you can see one option. So story drift. Or I want to know about the modal mass. So last class also I said the lump sum mass or modal mass. So building is like this. So where is my center of gravity? The more mass is acting. So I want to know about the central part where the building load is acting. So CG, with respect to CG, where my mass is acting. So I can give a simple command called print CG. So it will print my center of gravity of the structure, and it shows where the mass is going to occupy in my building. So right, so that we can see on this part CG, all these values. And section displacement. So what is the displacement happening at each node? So that can also be done over here. So to do this post analysis, basically we need a set of inputs. So what are the load classes you are using? So that should be used as same for post analysis also. So this also shows you mode shapes, how much mode shape you want. Like 6 set is the default value. So for mode shape, by default, 6 different type of mode shapes we can bring. So you can add 12 or 8 or 9, whatever the values you're going to give, you can bring it. Maximum around 20 to 24 we can give, maximum more than that. So 20 to 24 range we can give it. And then, so after doing all this part, so your analysis will be done. Now, ultimately, I need a output file to be print out. So I need some file to be print out. I need to submit to my client or to the contractor where I want to submit my report kind of thing. So for that, I need a analyzed report or a proper way of submitting my documents. So for that, in the analysis, you have some kind called print. So when you see here print, so what this print is going to do, so print is basically what all the inputs you're given, so that is going to print in your paper. So all the inputs which you have given by the user, so it is going to give you the member specification where you have released. Suppose in your model you have released certain properties, or you have grouped properties, or different kind of members you have used. So I want to know all the material kind of related or member related, all that should be printed out. So I can give this by using add. So ultimately at the end, it will show all my details which is available on my model, right? So all this can be done on this same part. So next part which we are going to discuss is most another part, that is your beam analysis. So manual versus a software. So over here we are going to do this a simple analytical model. So if you talk about a simple beam, a fixed beam, so you can see over here a simple beam is fixed on the both side. UDL is applied over here. So basically what we do, we take a paper and pen, we start solving all this, and then we draw the shear force diagram and bending moment diagram, and then you find the deflection value at the center and you get your results. So let's see that with the comparisons of the software. So how the software is going to compare it. So when you talk about the first very basic step in the theoretical value, that is on a calculation of self weight. So what is happening in a self weight? So we know the size of the beam. So we know the size of the beam, and you are adding with the unit weight of the concrete, and you're getting that value. So then the density which you're giving, so that will calculate your self weight of the beam. And then similarly, whatever the load you are going to act, some brick wall load or whatever the value given, so that we are going to take here. Now, on the other side, if you see in the software, we just simply give a self weight as -1. If you remember the very first step load case detail, you give as -1. And then you go to member load, you will add UDL -8. So the software will compute this part and it will show you this results, 10.43 kilonewton per meter. Right. So this is done by the load calculations. Now, after that, what is doing? So how it is calculating the bending moment diagram, shear force diagram. So here we take that total load on the overall span length, that is 5 meter, and we convert that into 52.18 kilonewton. And then you're getting the same value over here, the total summation of the load, what is acting on the beam. So I'll show this in STAAD Pro model also. I have this file. So I'll show you on this file how we are going to read this value in the output. So these are all the written output file, read from the output file. So you can take from your output file what we are going to get it there. So the bending moment formula, what you know, all the formulas we are applying. Yes, we know all this, and we are going to see that in the same in software. So immediately the software will show you the graph, like this kind of graphs you see on the software. So you get this output file directly. Now I want to know about the displacement. So what is happening at the displacement at center point? So I can use this formula and I can get it. So please correct, in the model I have taken 25, but in the theoretical I have changed as 20. So there will be minute variation in the deflections. So right. So here what we are knowing, so we know E value, we know I value. So all this formula you're calculating and you're getting your output file. So how the software is going to show the output? The software is going to show you the output as it is. So what you see in the bending moment at Z, so you can see what is happening on the both sides. So same value I have got over here on the screen. So you can see at the end 21.72 kilonewton meter. So yes, the same value I have achieved, but decimals, yes, there is a mathematical calculation, so the decimal will be varying. So I get 21.74. So here I got 21.72 kilonewton meter. So at the center, what is I'm going to, so center I have not showed, I think, yes, I have not showed the center point. So then for calculation of your deflection, so you can see at the center point 10.9. So yes, so where I got that, so you can check this part also. So substitute this, replace this as 25. So you'll get your answer for this also. So you got here also, it's 10.87, you can check that. Right, so I got 10.9. So like this, each and everything we can manually calculate, and you need to sit with the software and you need to see what is going in the software also. And another one you might be heard about, STAAD output file. So you might be got a STAAD output file. So output file, you see one simple calculation called summation of fx, summation of fy, summation of fz. So in this, the total summation of weight of the structure, whatever the structure, you see the value over here, fz, fy value will be reflecting. So how that is calculated? So I'll show you this again in the software. When I open the software, I'll show you what is this. So just have observation here. So it will show you fy value only. So remaining might be a negative or it might be 0. So the remaining values might be a 0 or it might be a negative value also. Mostly it will be zeros. So nearby case, it will be zeros. Right. So why it is showing in fy and how this value is coming here in this calculation is, it's purely on your node values. It's purely on node points. How many node points are there on your screen? Suppose I have 12 node point on my screen, the loads are applied to 12 node points completely. So that is your value, how you are going to get your part. Right. So if you have 2 nodes, so the answer will be reflecting for only 2 nodes. So like this, only this summation of fy will be reflecting in your STAAD Pro model. Now, after further that, what we are going to get is on a most important point, this load applications. So how you want to apply the loads for a plate and floor load. So this is the second topic which you are going to discuss for the day. So, and finally, you're getting certain results on the screen, 46.54 kilonewton in fy direction. And here in the picture, you can see some plate is attached here. So I have added a plate. Then I applied some loads here. then I get my results on the screen. So it clearly shows that plate analysis. So I have applied plate load. So here it is notable thing is I applied plate load concept. So I applied plate load concept. I'll show all these things in the software. Just note down whatever I'm discussing. Please note down the topic. Then you can catch this in the software. Right. Next part which you want to know is, so once you see the plate load, so you see this plate load is applied on the slab. So by seeing this, you can see this is in kilonewton per meter only. But when you see in software, the software is showing as a UDL load. So this is example, let us take 4 kilonewton meter square. So I applied this as a plate load, concentrated full plate load. But when I apply and select the plate, I apply this 4 kilonewton per meter square, it will not show like yield line. It is showing like it is running on the entire long beam and short beam as UDL. So what is happening here? The calculation behind is what? So it is taking as an area load. So kilonewton per meter square is converted into whatever the size of the slab you are taking, 6 meter into 4.5 meter. So this converts as 4. So whatever the value you are getting, so this will be in the total kilonewton value. So this will be calculated as a kilonewton values. Now, after knowing this value of kilonewton, how this is calculated, so this kilonewton value will now convert as, now suppose I'm going to get around what will be the answer here? It will be 6 into 4.5. So 27 into 4, you will be getting around 108 kilonewton. So now this 108 will be divided by 4 corners. So how many corners are there? 1, 2, 3, 4. So this will be divided by 4. So you will be getting around 27 kilonewton will be acting as a load on each corner, right? So you get this 27 kilonewton value on this part. So each 4 nodes you will be getting your value, right? So what happens here? So all this 27, so 27 will be calculated here. So this is the first concept of plate load. Further that what it is doing. So further that what it is doing is, so further that it is doing that the self weight of beam. So you know how to calculate the self weight of the beam. Size, you move the size of the beam into density of your concrete. So you will get that in kilonewton meter. Now, if you know this, how you can apply? So this is the self weight of the beam. Now you can apply this as WL by 2, WL by 2. So you come to know that in kilonewton plus 27 kilonewton will give you total nodal reactions. So that will give you total nodal reaction as 46.57 kilonewton. So when you see, when you go and do in post-processing analysis, when you use a node cursor, so when you use a node cursor, you come to know that it will be each node will have total value as 46.54 kilonewtons. So this is how the calculation is going. Now, further that, previously I was saying about this part. So FZ, sorry, FY. So what is happening in FY? Now this all into 4 times, into 4 node. How many nodes are present on my screen? So total 4 nodes is there. So 46.54 into 4. So that will be 186 will be summation value. Will be my summation of FY value. So that's what it is going to show you here. So next quickly what we are going to see is the next model is on floor load. Now I have a plate, I am having a plate, sorry, I have removed the plate, but I have applied a floor load. So I apply a floor load. So where you might be seeing that X range, Y range, and Z range. So when you apply this X, Y, Z range, so what is happening? The slab is taking as a yield line load. So slab is taking as a yield line load. So you can calculate this value by using a yield line concept or triangular load concept, whatever the concept you want to do. You can apply this, and here you can see the variation in the answer. So you see that variation in the answer. So that is 20.498. So I'm not giving any slab load here. So I removed my slabs. So plate is removed here. So why it is? So the concept is, when you use a floor load, the floor load is distributing the load to beam. The floor is distributing the load to beam element. So there is no need of drawing a plate element. So only we call it as finally RCC frame structure. Underline my word. So it is called as RCC frame structure. So we don't have any slabs. So just you see in a 3D, you see in any number of floors, you see only beam and column. So that is called a frame structure. So please make clear, right? So that is called a beam column connections of frame structure. Now you may ask whether I can add a plate and then I can use a floor load. Yes, you can add a plate and you can apply a floor load, but don't apply plate load. You should not apply plate load. So then the concept goes wrong. The concept goes completely wrong. So for residential building, whatever the building you're doing, so go for your floor load, but don't apply any plate element unnecessarily. So it is not required to make a structure RCC frame structure. We don't want any plate element to analyze. So self weight of the slabs you can consider, and you can add that separately in the calculations, right? So this is how you get your distribution of the forces, how the plate versus slab. The third concept which I was talking about, surface. Now surface is something unique application. Now where this surface is required, surface is required a special case of your retaining wall. Okay, so where you have certain retaining wall or shear walls or kind of basement structures. So where you have some kind of basement structures, we need to do this. So why we need this surface rather than plate or rather than the floor? So the surface is having a concept called meshing concept. So we have two types of meshing. One is a polygonal meshing, one is a quadrilateral meshing. So one is called polygonal, one is called quadrilateral. So what is this quadrilateral and polygonal? So polygonal meshing and quadrilateral meshing is again a background concept of finite element method, FEM method. So that shows that what kind of shape you need to draw the mesh. So what shape you need, how you want your structure to be drawn, a polygonal element or a complete perfect square rectangle box. So I can go for quadrilateral. Now you see in this picture, it's a perfect quadrilateral. So I have 4 nodes here, 1, 2, 3, 4. So I can draw completely a quadrilateral plate. But if I have a triangular plate like this, so how many nodes is there? So 1, 2, 3. So I will not go for quadrilateral. I'll go for polygonal. I'll go for polygonal. So this is the difference between two, polygonal and quadrilateral, right? So that the meshing will be done for these cases. So why meshing is required? Meshing is highly required to distribute the stress parameters. So if you want to see stress distributions or application of stresses or some kind of load retaining structures, then we need to do the meshing. Because in previous case, what happening in the previous case, we don't have any meshings here. The loads are completely distributing. So what kind of distribution? The slab load is taken care by beam. The beam load is taken care by the column, and the column load is taken care by the foundation. So the load distribution is there, right? But here the load is not distributed. The load is retaining. Something should be retained, or it should be withstanding, or it should be stable enough to protect. So if you're not doing the stress analysis for this particular part, your structure will fail. So by mistake, in your model, you're making a plate here and you're applying plate load, then it goes mistake, right? So I forgot to say one more application of the plate. So this part, so where I can apply this plate concept. So plate concept is highly used in your hydrostatics. So where you have a water tank structure, some water tank or fluid body or some kind of underground water tanks. So there I want to do some plate element. Then yes, I can go for plate element and make structures. Now, as I said, the previous concept, the 3 unit concept, what is happening between these 3? So very first part I said, so the application and what is the concept. So make sure we have a main 2 principle or basic analysis. One is called membrane, one is called shell. So these are the 2 words which you need to understand how this mechanism is working out. So when you say membrane, so the membrane is transforming, or it's accepting the force and it is deflecting and it is transferring to other members. Example, from the slab, beam is distributing to the column. So we'll analyze the slab as a membrane. But in case of shear wall or basement wall, that is called as shell element. That is called as shell elements. So the load is not transforming. The load is taken and is trying to deflect, or it is trying to restrain there only. It is a load bearing structures. So that is a basic concept where we see this membrane and shell. But yes, these 2 have a basic principle. We have a separate theory called plates and shells. If you talk about plates and shells, if this is a very MTech students might be knowing about it, plates and shell. So that is a basic concept how your area load, your floor loads, plate and surface are behaving as respect to a membrane and shell analysis, right? So this is a basic principle of analysis, how the software is doing this different kind of analysis part. Then coming to the last part today, we'll going to this part, structure wizard overview. So what is structure wizard? It's a predetermined structures, the pre-inputs. You can directly give the inputs and you get the various types of structures, a circular beam or arc. You can get your domes, all cooling towers. So where it is in geometry tab, and the last you can get your structure wizards. So once you click on structure wizard, you can get all your kind of structures, even a truss structures. So basically you have truss structures. So all these inputs you can give it over here and it will generate it. But those who are starting for the beginner level, I request please do not go directly to the structure wizard. Why? The reason I will tell you. The reason is, if you're going directly jumping to the structure wizard, you will not able to draw any structure which is given in future. So you'll be blind how to draw certain irregular structure or irregular geometry, or how you want to make the nodes and beam. So for my request for the beginner level students who are attending the boot camp, so just you can have a look on the structure wizard, how it is working. So this can be helpful in your future, but not right now. So just you can have a look on this part, right? So now let's quickly see all these results. What we discussed now, we'll see quickly in the STAAD model. So I'm sharing my screen right now. We'll go and see there in the live application how the software is going to apply there. Just I'm sharing my screen. Hold on it, please. Yes, it's loading right now. You can check it out. Okay, so the very first part which I want to show is on floor load. So you can see this floor load. The first example which I want to show here is on floor load. So the self weight is assigned to my structure. So this is a small span of 5 meter and 6 meter, and this is 4.5 I have taken for the example. So 6 and 4.5 slab size I have just taken for example purpose. And here you can see this pressure value. So you can see that is in a negative, minus 1.25 kilonewton. So here I don't have any ranges, so I just define as 0 range I have given here. And one thing you need to observe is one-way slab distribution. So wherever you might be studied one-way slabs, so wherever the one-way slabs to be done, basically another note. So where you can see application of one-way slab. So one-way slab application is highly seen in your cantilever portions in a balcony area. So where you see in a residential building, there we have one-way slab application. Second application in your staircase, wherever the staircase slabs are coming, the soffit slab, we call it as soffit, S-O-F-F-I-T, soffit slabs. So there we have the one-way slab distributions. And then the third application is in the corridor. So wherever you have certain kind of corridor applications, there you have a one-way slab distributions. So all this case, we can click a tick mark and you get the distribution for your span side. Now, let's see this result. I have not taken any plate here. If you see in the 3D rendering, you will not see any plate accepted there. So it is 0 there. Now, the load is distributed directly to the beams only. So it is taken care by the beams and it is distributing to the joints there. So when we run the analysis, so you come to know what is the value. So click on the node, go to reactions. You can come to know what is the reaction, 20.49824. Now multiply all this. You can take all the summation. So 20.498 into 4, you type, so 81.99. So you can go to a STAAD output, results. You can see this summation of force. As I said, 81.99, you got it. So if someone asks you how these values are coming, so you should be aware about it. The same way for the moment also. So what is the summation of moment? You need to calculate all this value. So summation of moment. So you need to do for this also. So this is the way you get your output, and you should be able to understand and read this. It's not that you done the work, your job is over. So if everybody is getting safe answer, so nobody is going to recruit you, right? So I can train a 12th standard student. I can give a training on the software. So these are the applications, just give this input. He can run the software and he can get the output file. But why as a civil engineer, you need it in the office? So why you are paid? So you need to check whether the software is giving right answer or not. So every software is giving a right answer, then why we need to recruit a civil engineer for the job? So that is the biggest question, right? So everybody will hire a 12th standard student or a diploma student. They will give training or they will give you part. So as a role of civil engineer everywhere, so we need to cross verify the results, either the software is showing the right answer or not. So what is the deflection is happening? It is within the limit or not? So all these are the cases we need to do, take care of it. Now you can go to the stress. So you can give the stress profile also. Now the question is how I want to get the stress profile. So when I rotate this part, you can see some kind of stress value. So just let me add it. Right. So I show you the stress displays here. So how the stresses are going to deflect. So for this, what you need to know, the basic formula which you have studied in the very, very long back ago, sigma is equal to m by I is equal to sigma by y E by R. So how to remember this? My teacher has taught me this very long back ago in 2007, I can say, but still I remember this formula. How? May I follow you, Elizabeth Rani? Very simple, tricky. So may I follow you, Elizabeth Rani? So very funny, right? So easily you can remember these equations. So from this, you bring this only this part. So sigma is equal to m by I into y. Calculate your stress parameters. What is the stress parameters is coming? So calculate your stress parameters. Check the section is safe or not, or you want to change the concrete grade. Check, do it. You will get your design outputs, right? So this is a simple part. So coming back to the model. So here you can check what is the maximum stress value. So 2.75. So that is my maximum section size. So if I change my section size, the stress will be varying or not, or grade. So you can cross verify it. So why? It is depending on the I value. It's purely depending on I value. So BDQ by 12. So if I change my size of section, so stress is inversely proportional here. So you can check that values. So right, so these are the part we can think about it. And then the second example, so going for the plate load. Now you see here in the second example, we have a plate here, and I applied a plate load here. So go to the load definition. You can go ahead here and check plate load. Now, if you see on the screen, it is not minus 1.5. It is positive direction. So you can see clearly here. It is 1.25. It's not minus. So if I apply minus, what happened? The pressure is coming from downwards. So you can see the screen. So the pressure is coming from downwards. So it is wrong. So as per the value, so I'm changing to positive, change that. So you get your values now. So you can run the analysis again. You run and you take to post-processing, apply. Now see the reactions, 46.54. So how this is going to get that? So you will get your values output. Now add all this summation of this. What you get over here is output 5. Summation of your reaction 186.19. I got the answer. Right? So this is a way we can get your answers. Now same way, if you want to know the plate stresses, what is the plate stresses? For plate stresses, we have a concept called von Mises. We have called von Mises. So this is a theory analysis for plate stress. So wherever the plate stress is coming, so we can use this von Mises principle. So what this von Mises principle is saying, it shows you the plate stresses. So where the stresses are distributed. So suppose this is a plate. So at each corner, so what is happening in the corner, what is happening in the center, it will show my stresses. But in order to get in perfect way, I always suggest you do a floor analysis. If you remember that part where you see the space and you have seen the plane and you have seen the floor when you start the software, right? So when you start the software, it will ask you space, plane, floor, truss. But when I want to study only about the slab analysis, purely about slab analysis or slab stress, then preferable you go for floor analysis and do the meshing. So you can add for meshing concept, and then you get your answers done from the software. But yes, in STAAD Pro, we don't get RCC detailing for slab. We don't get a detailing part, but this is possible in STAAD Connect Edition. It is possible to get your STAAD slab reinforcement diagram in Connect Edition software, STAAD Pro with Connect Edition. So you can get there the RCC detailing, slab grids, everything can be done over there, right? So that is our advanced slab software of STAAD Pro, right? So in a beginning, a basic level, we don't get anything. We get only the stress value for each corner, and we find out that. So in order to simply see the stresses, you can see that simply over here, von Mises. You can give that, and you can see that with normal fill, apply. So here, since we don't have any meshings, the floor load is not applicable here. So in order to get the value, we need to do the meshings, right? So if time permit, I'll show you in the last. So you need to do the meshings over here. So you can see this generate surface meshing. So you can go for generate surface meshing. It will show the meshing patterns. You can see the cursor is changed now. It shows a small grids there. So that is called meshing. So I want to do the meshing first. Then only the answer will be reflecting on my screen. Okay, so let us come to this next part. Later on, I'll do the meshing and we'll show you that. Now, on the third part, which is on the beam. So as I showed the very first example, number 1, a fixed beam. So the beam is there. So load is applicable. Everything is there. So whatever the value you are given, so you are getting all your displacements, all your values you are getting at 2.5 meter. So what is my displacements? So here we can get directly on this part. Now, same way for shear force diagram also, we got all the data over here. So these are the things which you get for your part. Next part which I want to show is on your meshings. So what is happening in meshings? So meshing is how you want to do this part. So here you can see this meshing. Its color is green color. You can see some kind of green color. Previous it was pink color. So here you can see this green color. So as I said, for shear wall design, you can see on my screen, some design is running on there. on the right side, shear wall design. So I've done the shear wall design for this particular model. So I'll get the output for shear walls. So what is the value? What is the grade of concrete is used, and what is the value? And most important point, thickness should not be less than 300. Basically, for shear wall, one basic principle. So for higher students who are working in a STAAD Pro, please make sure your thickness should not be less than 300 mm. The code says that. So take care of it. So for students who are dealing with the shear walls. So here you can see the drift analysis, how much amount it is passed. So what is the limitation values also. So you can get your mode shapes also. So sorry, it's ignored in this model. So I not added that. So these are the values you will be getting when you run a surface meshing concept. So all complete design you get here for this part also. Right, so we are going to discuss this tomorrow in the design concept. I'll be coming over here tomorrow, day 5. We'll be discussing on design aspects. Right, so here you can see the meshing, how I want to see the meshings. You can see the meshings over here. Right, so next one, most important concept, this request from some student. So openings. So last class we are discussing about non-load bearing walls. Non-load bearing walls. Now I have certain kind of shear walls or some kind of load bearing wall. I have to create some opening in the structure, or you are a slab, roof slab, your interior staircase. So when you have an interior staircase, so in your houses you have interior staircase, right? So what happened? There will be a small opening in your house slab, roof slabs. So the staircase will be connected here, and you will be entering, getting from here to the terrace or the next floor level, and you give some handrail portions. So how to create this kind of opening in this part? So when you see that in plate, it is not possible. So this is a plate model, I guess. Yes. Yeah. This is a plate model. So here, if I think about opening, it will show a valid surface is not applicable. So please make a note, for any kind of openings, we need to go for surface only. We should not go for plate. So make my word clearly. For that, we need a surface. We should not have a plate. So when I have a surface, you can see this example. For example, I'm taking the same model. I'm going to create some opening over here. So a certain third slab, I'm just going to open a small opening. So here is option called opening. Insert opening in this surface. So you can click on this particular part and it'll ask you where you want to draw it. So suppose I want to draw certain here. So you can draw this over this meshing part. Sorry, it is a, let me take a new file. So that is much better. So just you can create a new surface opening. And I'll show you meshing concept also right now. So let me take this part. Let it be in XY. I'm doing in XY. So let us take a 5 meter, 6 meter, 5 meter, and closing it. Now I'm going to add the surface to this. So you can go to geometry, add surface. Click on add surface. 1, 2, 3, 4, and 5. So surface is done. So you can add the surface. Now you can go to the geometry properties, go to thickness, where we see two different properties. One is plate thickness, one is surface thickness. So surface thickness, I'm going to enter a thickness called 300 mm. I'm adding that. Now close this, select your surface cursor. You need to select a surface cursor. So this is called plate cursor. This is called surface cursor. Select that. So you can see this is assigned to this part. Now I want to open a small structure here. So click on opening. Where you want the openings? I want the opening here. Some kind of window or ventilation system is there. So I made an opening there. Now you can see that in 3D. The opening is provided. So you can detect the weight again with the load bearings, and then you can apply the structure. So such cases are used in case of shear wall openings or staircase with shear walls. All this case will be helpful for you to create openings there. Then coming to meshing now. So same concept using meshing. Suppose I want to do the meshing for this. So going back to the previous steps. So for meshing, what we can do, we can go for surface, generate surface meshing. So you can get it that from geometry, surface meshing. Now click on the start, second, third, fourth, and fifth. So what I said in the class, I said you that polygonal and quadrilateral meshings. So what type of meshing you need? So it is a perfect quadrilateral. So I don't want to go for polygonals. So it will make a small triangles over there. So rather than that perfect meshing I need, so I'm just going for quadrilateral. So it will show what length you want to cut your mesh. So each one small division, one meter or small meters I want to divide. So it shows the length 6 meter by 5 meter. It is going to divide by 1 segments. So I can say that if I want to modify, I can modify my divisions. So suppose I need 15 divisions in each section. So I can type it as 15 sections. Small meshing is going to create. Right? You can click apply. So you can see small meshings on the screen. So this is a meshing concept. Let me do the quadrilateral. Let me show you the quadrilateral also. So I'm just doing the again, undo it, and doing again. Now I'm going to show you the polygonal. So go for polygonal. So now when I give a polygonal, let's see what is going to see. You can see small triangle on this part. So where polygonal meshing is used, so when you have irregular structures, so polygonal meshing is highly used when you have irregular structures. So like curved beams, you have some kind of curved beams like this, a slab is like this. So I can make certain cases where this possible meshings are available. I can go for a quadrilateral meshings. So I'll do this as a quadrilateral meshings. So this as a one quadrilateral meshings. So at the edge corner, you can see these are all not perfect quadrilaterals. So I can't do a 4-noded plate. So rather than that, it can be a polygonal meshings. So irregular polygonal meshings can be possible at this kind of cases. So this is the difference between your polygonal and rectangle. So when you have a perfect body of rectangles, so you can go for this. So I'm just undoing. I'm coming back to normal quadrilateral. Right. So done with that. So click OK. So let's proceed with by default. Right. Now let's give the supports quickly and we'll see the stress one miss as I said. So you can give that. Yeah. Then loads. So let's give some loads. Dead load. Okay. Fine. Add a self weight for the structure. Now the most important thing, pay attention here. So you need to understand the floor load. So area load has a direction of 1 local coordinates. So here also units, as I said, kilonewton per meter square, but area load have 1 local coordinates and 3 global coordinates. So you can apply for all global axis, but with respect to 1 local axis only. Right. Now, similar way for floor load, you have the pressure load distribution. It is also possible all 3 global direction with specific ranges, Y range, Z range, X range. As I showed, your room dimension differs. You need to work on this part. So what is the dimensions? You need to give properly. So what is the use of this? When you have different kind of thickness of slab, suppose you have a diagram like this. So I have a hall, bedroom, kitchen like this. So this is a hall, big room. And here I have certain cases like this. Right. So this is slab 125 mm. This is slab 150 mm. And this is again 100 mm. And this is also 150 mm slab thickness. Suppose a design is like this. So I need to know what is the X range. So X is 0, 0, 0. So let us take this as 5 meter, 5, 0, 0. Let us take another 5. So let us take 10, 10. So when I assign this particular portion, right? So what is X range? It is 10. Similarly for Z direction, let us take this as Z. So this point will be now 3 meter. So 0, 0, 3. And let us take this point 0, 0, 7. And let us take this as again 0, 0, 12. So when I need to know about this particular point, so I'll take X range is 5 and 10. So I will give that here the number of students do mistake here. So they will not understand this concept. They simply blindly give a 0, 0, 0. So please understand this concept, 5 and your 10. So when you give this kind of range, the loads will be reflecting on this particular portion where I shaded, right? So please note that. So let's add a surface load here. So I'll go to surface, then plate. So you can see the plate load, full pressure on plate load. So this also have same unit. So this is happening for this. So this hydrostatic, what I was discussing on the water tank design. So we need to select a particular plate and we apply this water tank pressure. So wherever the pressure water tank is coming, so partial pressure, fully filled, you might be studied in the subjects. So like this, it's partially filled, or retaining structure wall, you are happening like this, or full wall pressure. So like this. So like this, we need to select the plate and you need to give for all the plate boundaries. And last, finally, we have the surface load. Click on surface and whatever the load you want to give on the pressure. So give that as my 4. That. Now select that plate, use surface cursor, assign this to the selected surface. Yes, and sulfate to the view. Right. So if you want to add the beams, you can add the beams on the all 4 edges. Without beam, it will show error mostly. Let's see it. So it will start doing the meshing concept. So how many? So the property is not assigned. Sorry. Properties. Go to the properties. I guess missed with my meshing. Warning. Yes, there's the same joint load repeated. So due to that, warning is coming. Okay, fine. This many warnings. Member load is missing. So as I said, I need to add a beams also. So all 4 nodes, the beam should be added. So let us go back to my previous shear wall. I have completed the model. It takes more time there. So yeah, this you can see that. The same concept. So once you run the analysis, it do all the meshing concepts, then it'll take the generate meshing, and then it gives you our answers there. So this is how it takes for the meshing concept. Okay, so we are going to stop it right now here, and we are going to come back to the class session. Right. So going back to the class, again coming back over here. Yes. So that's a day we have completed. So structure wizard, please have a look. So I'll cover that part tomorrow again with the structure wizards. So structure wizards, why I'm not teaching is beginner level, you need to learn certain things. For a higher level, it is easy. So you can understand the structure wizard directly. You can give the inputs, you get your models done there. Even curved beams, circular beams, you can get to done over there. So when you know that particular applications, directly you can go for it. But please understand the working principle, how these calculations are running behind the software versus model. That is highly useful. So the tips for the day is today, what you can do is further this session, you just take any structural analysis book. You can take one structural analysis book and you can do this same example. You can work out for this fixed beam or simply supported beam. You take one fixed beam, you give yourself any loads, whichever you like to give any loads on the structure, take any size of the beam and make a manual calculation like this. So you can have this part. So just do a manual calculation like this. Then do the same model in STAAD Pro, draw the beam, apply the loads and see whether your answer is matching or not. What I showed in the output file, EY, summation of EX, all that values are matching or not. You can come to know that. And secondly, for the slabs, what you do, the same way, you take some slabs and do the analysis and try to get this answer is matching or not, right? So with this, I'm just stopping here. and we'll come back to the feedback sessions. You can give your feedbacks. So please post your feedbacks for the day 4. Right. So we'll go for question now. So we'll discuss with certain questions, how certain important parts we want to discuss. We can go ahead with that. Right. So I'm posting the feedback sessions today. You can go ahead for that. So thank you for the day 4. So we'll close the session right now, and we'll be going further to the question sessions, and we'll discuss with questions what we are going to discuss today. Right. So thank you for all for the participant attending for the day 4. Meet you tomorrow. So tomorrow we are going to discuss with the design inputs with IS 456. What are the basic inputs you need to give, and what are the 3 methods of RCC design, how you want to start with RCC design in STAAD Pro. Right. So thank you for all. Meet you tomorrow.